Hello folks. So in this tutorial, I'm going to talk about feature scaling, which is an integral part of machine learning. Okay, and since many of our times you might have encountered a situation where one of your independent variable had very small numeric values and another one had very large numeric values. So how to bring such column values on a same scale for more accurate machine learning prediction is something which I'm going to talk about in this video. Okay. So folks, this is Nitin, who is determined to democratize the artificial intelligence, big data, Hadoop, and cloud computing to the world. Okay, and with this aim, I will be creating associated content and going to publish that very content periodically and made it available for you. So you can subscribe to my channel to get the latest updates regarding these hottest technologies of the 21st century. All right. So let's see what feature scaling is and why do we need it. Okay, we will consider a diabetes data set for this tutorial. So let's consider two columns here, which are basically pregnancies and glucose. So this is the data set, right? So you can see there is a column pregnancies and then there is a glucose column, right? And the reason why are we choosing this, because in the pregnancies you can see the the values are very small, whereas in glucose the values are large, right? So you can see that values in these two columns are not on same scale, right? And since these two columns are not on same scale, so it may lead to some problems in your machine learning model. And this is because most of the machine learning models are based on Euclidean distance, right? So Euclidean distance is let me show you the Euclidean distance equation. So here is this Euclidean distance equation, right? And you can see the diagram that there are two data points, x1 y1 and x2 y2, and the Euclidean distance is the distance between these 2 points in this xy space. Okay, and this is the equation. So basically this is the way we find out the distance between 2 points. So Euclidean distance between 2 points is the square root of sum of square coordinates. And since the this glucose value or glucose attribute has much wider range of values, so Euclidean distance will be dominated by this particular column. Okay, and let me show you something here. Let me calculate the distance between 2 points for these two columns, and then you will be able to figure it out. Okay. So let's consider 2 points, okay, for both pregnancies column and glucose column. Let me say these are the 2 points. First one is this one, okay, and second one is this one. And similarly for glucose. And so for the same index, we are choosing these 2 point values for pregnancy as well as glucose. So let's calculate the distance for pregnancies between these two, or the Euclidean distance between these 2 points. Okay, so it is something like, so this minus this, okay, and then the square of this value, okay, and it is coming as 4. So this is pregnancies. Okay, now similarly let's calculate for glucose. Okay, here the value would be, let us say equals to 183 minus 148, and then the square of it. So you can see it is 1225. Okay, so the difference between these two Euclidean distances is quite drastic, quite huge, So glucose is quite a huge value as compared to pregnancies, right? So you can see that pregnancies is dominated by glucose. So machine learning model will treat that squared value of pregnancies as doesn't exist, right? So this is the reason we need to put the variable on the same scale, right? And we will do some kind of transformation to bring them on a scale, that is values, let us say, ranging from -1 to +1, etc. So in order to basically so that we don't get an issue where huge number dominating a small number. And there are several ways to scale the data. So there are basically a couple of ways out of those, and which are normalization and standardization. So in standardization, we subtract the mean value from individual observation value and divide that information by standard deviation. And in case of normalization, we subtract the minimum value from the observation and then divided it with the difference of maximum and minimum feature value. So essentially, by doing this, we are keeping the variable in the same range and scale. One thing to note here is that if, let's say, a machine learning model is not based on Euclidean distance, then also we would need to do feature scaling because the algorithm converges much faster. So one such example is decision trees, where which are not based on Euclidean distances, and if we don't do feature scaling for this particular algorithm, then it will run for very long time. So in this tutorial, we are going to use another data set called diabetes dataset. And we will be creating the feature matrix as well as dependent vector column for that particular data set. And after that, we will be kind of splitting it up into training and test data set, and thereafter we will be doing some feature scaling for that. Okay, so let's do some coding here. So let's type the code for the same. So we'll create a data frame with the name dataset equals to pd.read csv, and then the name of the CSV file is diabetes.csv. Okay, and then after that we will create the feature matrix X, which is and then the dependent column vector. Okay, so this is the way. We have already performed some of these steps previously also. Usage of iloc and all that, all those commands, right? So iloc and then comma -1. So we are essentially choosing all the basically all the columns except the last column. Okay, values, and similarly we will do it for y as well. Okay, and in this case we will be choosing, so here if you see 0 1 2 3 4 5 6 7 8, so this is the 8th index column. Okay, so which is the outcome variable, dependent variable we want to keep in y. Okay, so we want to keep that value in y, independent variable values. Okay, so here it is done. Now let's run this cell, and then after this what we are going to do is we are going to basically let's do one thing. Let's take a look at the data, some of the data set some of the observations. Okay, so these are some of the observations, right? And then next I'm going to write one command This command is basically used to show all the element values of an array. Okay, so later on down the line I will be creating the training and test data sets. So X is the feature matrix, right, which constitutes 8 columns. Now there are times when we have 100 columns, and if we want to see the value of each and every column in that feature matrix, then we can make use of this command, which I'm going to write. Otherwise what it will do is it will show some of the column values, and then there is a dot 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 in between. So it does essentially, it doesn't show all the column values of that feature matrix, right? But if in case we want to see all the values of the feature matrix, okay, then we can insert this command, and using which it will show all the values. I will tell you like what I'm trying to say here. So let's type that. So np dot set print options, and then edge items equals to 127. So this is the command. Let's run that command, and now we are going to create our training and test data sets, or training sets or test sets, right? So for that, before that, we need to basically import the library. So from Sklearn, the corresponding library, pre-processing, and then import train test split, right? And after that we will create the corresponding feature matrix and dependent vectors for both training and test dataset. So xtrain, xtest, ytrain, ytest, and then after that we will be utilizing this class, which is train test split, and then after that we will be providing the parameter values. One is feature matrix, another one is dependent vector, and then the test size. Okay, so test size equals to 0.2. all right, so this is done. Okay, so some typo here, pre-processing. It looks like some typo again here. Oh yes, so it's not pre-processing, it's model selection. So the library name is model selection. Okay, let's do that. Okay, now the next step is to basically okay, so the next step is to write introduce the library called the pre-processing library, wherein the class is standard scaler, which will do some feature scaling for us. Okay, and again the library in this case is sklearn.preprocessing only. Okay, so let's do that, and the library is from sklearn.preprocessing import standard scaler. Okay, and there is no space. Okay, so this is the class, standard scaler class, which actually performs the feature scaling for the variables or the attributes of, or the columns of the data frame. Okay, and once this is done, then we will create the object of this class, standard scaler class. Okay, so we will name the object as std scaler, and then standard scaler. Okay, so this is done, and then I would like to basically highlight one thing here. So let's say you have split up your training and test data set before this feature scaling step. Okay, so you need to fit and transform your training data set, but only need to transform the test data set, meaning you don't need to do both fit and transform for test data set, because fitting is already done on training data set. That is, code will meaning that the training, since the training fit and transform is done on training data set, we are not required to do fit on test data set. Only transform is required for test set. Okay, so what we will write, the next statement is xtrain equals to std scalar. Let me tell you like what I'm trying to say here. So std scalar fit transform, okay, and then x train. Okay, so this is, we are doing fit transform for x train, right? But for test we are going to do just transform, okay, because fit transform is also already done on training data set or training set. Okay, so that's what I meant, fit transform on training set and only transform on test set. Okay, so this is the way we do it. Now let's check the value of x train. Okay, standard scale. Oh yes, there is a typo, so it's E basically, not A here. Okay, so now you can see that the values are on the same scale. Okay, so you can see that there is no huge value or small value, right? So values are on the same scale here, correct? And when I mentioned this statement np.set print options edge items equals to 127, what I meant to say was, here you will be able to see all the values pertaining this feature matrix. But if in case you haven't provided that particular line of code, then the values might be like this value, then dot 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 dot, and then this value and this value. So you won't be able to see all the values up front, right? But using that statement, I am able to see all the values of particular observation in this feature matrix, right? So that was the whole intent of using that statement, this statement. Okay, so using or try to visualize all the feature values of the feature matrix, okay, or all the attribute values of the feature matrix, okay, in one go. All right, now you might ask if we need to do feature scaling of one hot encoded values as well. Well, that depends upon the context, that is how much interpretation you want to keep in your model. Although it would be good to feature scale them since everything will be on the same scale and you will get good prediction, but you will lose interpretation, because then you won't be able to figure out which value depicts which value depicts what. For example, if I talk about, let us say if there are two one hot encoded values like female and male, and we transformed into 0 1, and then we created the one hot encoded values, then after doing this type of feature scaling, you won't be able to determine which value is which, even though in this case you would be able to, because there are only two values. But let us say if there are 5 categories or 6 categories in that particular column, then in that case you won't be able to figure out. Okay, so that depends upon the context of you're using those one hot encoded values. Now you might also ask if we need to do feature scaling for dependent variables. Well, the answer is no for classification problems where the dependent variable is categorical in nature. And the questions, the categorical in nature, meaning where you ask the questions like yes, no, 0 1, spam or not spam, etc., those kind of classification. And in case of regression problems where dependent variable, let's say, has use values, we need to perform feature scaling for sure on dependent variable or target variable, because you need to scale down the values, right? So folks, this is it for this video, and to conclude, we learned about feature scaling in this section, which is a way using which we can bring numerical variables who has values on different scale to the same scale in order to make it usable for machine learning model and for better predictions, right? Now I have a question here. How many times you have encountered a situation when you perform feature scaling of independent variable in a data science project, and what were some of the challenges you encountered? Please share your experiences in the comment section given below. Okay, we would like to hear from you. And if you are watching this video and you are not already a subscriber to our channel, consider clicking that subscriber button below. In case you have already subscribed, then click on bell icon to receive the notification whenever I will release the new video. So thanks for hanging out with us, guys. I will be covering next topic in the upcoming video, so keep on watching. Thank you.